is just a little example of a dice not necessarily having to be fair, right? This dice would be nicer if you were to play with your partners and you were going for the sixes, right? You could have a dice that could have a structure like this with 1/7 for 5 of them and then 2/7 for the 6. You could, if you had a bit of mechanical intelligence, you could construct a little dice with a little extra metal thing close to the 6, or you could construct it such, or close to the 1, of course, sorry. I'm not an engineer, but I'm trying to be. But if you then construct such a dice such that it more often will come out with a 6, let's try to simulate that by R. Sorry for the Danish again. Let me just now talk about it, and then we can then do it in a sec. I sampled the 1 to 6, still I do it 30 times. Still, I replace such that I each time sample between 1 to 6, otherwise what we do doesn't really make sense, because the default is something different, but then we will get an error. So for this to make sense, we need to tell it to always do it among all of the 1 to 6 here. And then I'd specify the probabilities, not the 6 times 1/6 as it would use by default, but I specify 5 1/7 and 1 2/7. And if they didn't add up to 1, the function would give an error and ask you to give some probabilities that adds up to 1. Then I plot the whole thing as we did before. Let's look at what comes out of this. So these were all, it's difficult to see of course, but these are exactly what I showed you. See what happens. The black ones are the observed frequencies or relative frequencies, and the red ones are the theoretical ones. Showing us again that observed data will never obey 100% to the theoretical ones, but we need to learn how to learn from them anyway. That's the core of statistics, to learn from observed data and knowing how close to the truth we are, in a way. That's what all comes in the rest of the course. So still, that was an example of a probability density function that could be many different things from this first simple one also. Should we try to just finish off this example by solving this one? What is the probability to get a 4? Anyone who wants to participate in the little game? No trick question, so it's easy. 1/7, of course, that's how I defined it. What's the probability to get a 5 or a 6? This is basic stuff. No, it's not a trick in any way. Use common sense and you get the right answer. 3/7 because 1 for the 5 and 2 for the 6, and that makes 3/7, right? And what is less than 3? Yeah, 2/7 because there's 1 or 2. Perfect. You're already ready to move on. So let's move on. So